Let's talk about Cubeo, especially its weird day and night cycle and seasons. Cubeo 3 is the home planet of the Prismatic Imperium in the Cubeo system, and it comes with an awkward quirk, which is the 82.67 degree actual tilt that the planet has. That comes with a bunch of interesting complications when it comes to the day and night cycle and its seasons. Unfortunately, we can visualize that so we can get a better understanding of what's going on. In order to accomplish this and make it easier to see how the actual tilt affects Cubeo 3, I have kind of recreated the entire Cubeo system in the SpaceEngine game software, whatever you want to call it. And while this may not all be super accurate, and Cubeo 3 is a terraformed planet, so when it comes to like atmosphere and landmass, it is not an accurate representation, but nevertheless, with basically copying the Earth's surface and atmosphere configuration over to roughly emulate an Earth-like world, we can still visualize what we're looking for. In this picture you can already see the actual tilt visualized. Instead of rotating kind of perpendicular to the orbital plane of the solar system like the Earth does, we have a planet that is kind of facing into this plane. The animation shows how the Cubeo 3 planet passes around the Cubeo star. And as you can see, due to the actual tilt, we have the phenomenon that there's a very pronounced northern and southern summer that kind of extends to almost the entire hemisphere. Basically, in the North Pole you will have a phase where it's constantly day in the North summer, and in the South summer, which is the North winter, you will have a constant period of a night. And the Cubeo year lasts around like 600 days, so it's a very long time in which you will have either light all the time or no light. So the obvious solution, if you want to build a city on it, would be to go somewhere near the equator to at least make your day and night cycle somewhat consistent throughout the year. But what does that cycle look like? First of all, we visualize the day and night cycle on the equator when it is summer in the north. A Cubeo 3 day lasts for about 31.5 hours. On the equator, the day and night will always be roughly equal in length, which is the entire point of choosing it as the location. In the North summer, the sun will look like it is rotating in just a small circle around the North Pole. It will be a close to sunset day for about 15.5 hours, and then the night will consist of almost never-ending twilight for the remaining 15.5 hours. You can call it spring or fall, but as the planet orbits around the star, the path of the sun will become more circular until we have what we could call the Equatorial summer, about 90 degrees after the North summer. It will have mostly normal lighting. Days will be bright with the sun from above around noon, while the nights will be dark as we probably know them from many places on Earth. Note that the day and night still have about the same duration. The sun simply moves faster across the sky. The planet continues on its almost 2-year-long journey around the star, and another 90 degrees later we achieve the South summer. It looks mostly like the North summer, except the sun will now rise and set towards the south. Once again, its path is becoming a smaller circle, despite a day still lasting the same time. Likewise, the nights are in a constant state of twilight. The next equatorial summer, as the planet is on the trip back towards the North Summer, will look very much like the one we have seen before. Instead, let's have a look at halfway there, about 220 degrees in. We have what we can call an almost usual day. What is interesting is the night. While it's not necessarily eternal twilight, we basically can follow a shallow twilight on the horizon, from the point of sunset over to the point of sunrise. As I said, staying around the equator is the point if we want a mostly regular cycle. If we were at the coordinates of the city of London, would it be on Cubeo 3, we would see the North Summer like this. There's no sunset for many months, and the sun just circles around high in the sky. You better bring good sunscreen if you go here for a vacation. In the Londonese winter, there would be no sunrise for months. Aside from the occasional twilight, the main source of light in the sky would be our moon, Cubeo 3a. By the way, Cubeo 3a also has an orbit around the planet that is almost perpendicular to the plane of the star system. That means you would never have any solar or lunar eclipse. The moon would always be in a phase where it is some kind of lit. It's honestly an easy way to keep out werewolves. If you're a werewolf, well, my apologies. I think at this point I should stop talking. I hope I could answer a bunch of questions about how the day-night cycle would look like visually and how the seasons would affect it. I hope the SpaceEngine recordings did a good job of highlighting that, and my apologies for some minor camera movement I had in those. The recordings we saw so far used the 45-degree field of view, which should be mostly natural side. And before I end this video, I will stop talking, but I will show you a full, like 8-minute time lapse of an entire year from somewhere in Africa around the equator. So you can see an entire year as a time lapse, what it would look like in a sped up version. The field of view used for this recording is 90 degrees, so it's a wider angle. Keep that in mind. I hope that was informative and enjoyable. I wish everyone a good day or night or whatever time it is.